Hello, my dear students. So, in the previous lecture, we have seen how we can convert an octal number to the decimal number, and we have also seen how we can convert a decimal number to the octal number. Okay, and in the previous class, we have seen how we can convert a binary number to the decimal number, and we have also seen how we can convert a decimal number to the binary number. Okay. So in this lecture, we are going to focus on these two methods. That means we are going to convert a hexadecimal number to the decimal number, and we are going to convert a decimal number into the hexadecimal number. So before we proceed with this conversion method, let me quickly revise what is this hexadecimal number actually. So our hexadecimal number starts from 0 to 15. Okay, and I have already mentioned you from 10 onwards up to 9 is okay. From 10 to represent 10, we are going to represent 10 as by A, 11 by B, 12 by C, 13 by D, 14 by E, and 15 by F in order to indicate this 10, 11, 12, 13, 14, 15. These numbers we represent by this alphabet A, B, C, D up to F, because our hexadecimal number starts from 0 to 15. Okay, let's take one example of this hexadecimal number. Okay, example is suppose a hexadecimal, it can be suppose E to A. Okay, so E to A, when you look at this kind of number, easily you can say this is a hexadecimal number. Why? Because in this number some alphabetic representation is there. Okay, so we can easily say that this is a hexadecimal number. Now suppose in examination, suppose they want a number, because suppose this is a number. Okay, this, it can be decimal and it can be hexadecimal also. In order to indicate this as hexadecimal, they will give like this. Okay, so in that case you will easily identify that this is a hexadecimal number. Okay, now especially we are going to focus with this method, that is hexadecimal to decimal. So let's take one example. Suppose 7A2. This is a hexadecimal number, and you have to convert it to the decimal number, or you can say 10. Okay, how we can convert this number? Let's take the number. Okay, as you know, from any number to decimal number, we are going to focus on multiplication method. And to go for multiplication method, first of all we have to find the place value. What is the place value for this 2? Remember, this time we are talking about hexadecimal number. So place value will be 16 to the power 0. Place value for A will be 16 to the power 1, and place value for A will be 16 to the power 2. Right? So how we can convert? Digit is 2, so 2 into place value is 16 to the power 0. For A, we cannot write here A. Yes, let's write, okay, A into 16 to the power 1. Okay, now we cannot multiply 16 with A, right? So what we have to do? We have to write here the equivalent number for A. You can see here A is 10. So we write here 10 into 16 to the power 1. For 7 into 16 to the power 2. So now multiply it and add this number. Okay, so 16 to the power 0 is 1, 1 into 2 is 2. 16 to the power 1 is 16 into 10 equal to 160. Okay, and 16 square is 256 into 7. Okay, okay, 3, 7. That means 1792. Now add this 3, you will get the decimal number for this hexadecimal number. So 2, 2, 4, 6, 9, 15, 1, okay, 1, 8, 9. That means therefore 7A2 equal to 1954. So this was our hexadecimal number, and we got this decimal number, right? So this is how we can convert. See, it is very simple. Already we have seen same method we are doing, same method we did here, same method we applied here. Okay, that just the difference is what here we use place value for and we use base 2. Here we use base as 8 and here we are using base as 16. That is the difference. Else everything is similar with previous method. Okay. Now sometimes in exam they might give some fraction portion also. So suppose we have here 0.1a. So in this case also similar goes for this also. For 1 the place value, just we need to find out place value. Okay. So for suppose 0.1a here. Okay. So for 1 place value is 16 to the power minus 1 and for a 16 to the power minus 2. So multiply this 1 into 16 to the power minus 1 and multiply this a into 16 to the power minus 2. Okay, you add it and solve it, you will get the fraction part also. I think I do not have to explain it again because it is similar with these two methods. Okay, now what we'll do, we will see how we can convert a decimal number to the hexadecimal number. Okay, let's take this decimal number only. Okay, so decimal to the hexadecimal number. Our number here is 1. This is 6 method. Okay, so number here is 1954, right? So this is our decimal number and we have to find the equivalent hexadecimal number. So in order to find hexadecimal number, see again we are going to use that trick. Okay, that means from decimal number to any number we are going to focus on division method. Okay, so let's divide this number 1954. This time we are going to divide it by 16. Why? Because we are going to convert decimal to hexadecimal. Okay, so let's divide this number. It will be 1. Okay, so carry over with 3. That means 35 2. Okay, 2 again 3 34 2. Carry over, remainder will be 2. Okay, 122. Now if you divide 122 by 16, we can divide, I think 16 6 are 96, 16 7 are. Okay, 16 7 are 100, 112, I think, yes, 112. So 112. Okay, what will be the remainder? Remainder will be 10, right? So 10 we can represent it by a also. That means 1954 equal to 7. We are not going to write here 10 because ultimately we are representing hexadecimal number. In order to represent hexadecimal number, we will write here the equivalent alphabetic number. Okay, alphabets. So for 10, A, and this is 2 because we use this method, bottom to the top method. Okay, so this is your decimal and this is your hexadecimal number. So this is how we can convert a decimal number to the hexadecimal number. Now in this case also, suppose we have fraction part. So what you will do for fraction part, what you will do, fraction part into 16. Okay, multiply it and you keep the integer portion. Same method with this also. Okay, so I hope this is clear because this is quite similar with the previous 4 method. Okay, so with this I am going to conclude this 6 conversion method. Okay, and next lecture, or you can say in the next class, we are going to convert. I hope this is clear. Okay, just pause the video and write it down. Okay, you write it down. So in the next class we are going to discuss some more conversion method. That means say we have binary to octal. Okay, octal to binary. These are the very simple method we are going to learn it because here we are not going to use any multiplication method and we are not going to use any division method also. Okay, so say octal to the hexadecimal and hexadecimal to octal. Okay, again hexadecimal to binary and our last conversion method is binary to hexadecimal. So this conversion method we are in this sixth conversion method we are not going to use this division method and multiplication method. Okay, here it is very simple, just we need to know the binary number because we already know what is binary number. Okay, so easily we can find it out. Okay, so with this I'm going to stop here. Okay, let's see in the next class. Okay, thank you.